Hello everyone, we will be working on Numpy. So basically we will be combining Numpy, Matplotlib and then Raster Data, different libraries. Previously you learned how you can plot your data using Matplotlib. We will use that technique so that we can plot our raster data using Numpy. So Numpy is more of how we can digitize our data, how we can convert our dataset into 2-dimension or maybe 3-dimension or maybe more dimensional dataset where we can assign numbers in a systematic way. You can see over here I added Numpy. And then I said that today's topic is reading raster data into Numpy array and visualize them using Matplotlib. That means we will be combining Raster Data library, Numpy, and then Matplotlib, 3 items, but we also need a few more to work on our raster data analysis. So learning objectives for us is how we can compute numerical analysis using Numpy. In Numpy, you will be learning how we can work on array, how we can create array, how we can access array, and then use different libraries, how we can generate random numbers, then slice our array, and some math operations we will be working on using Numpy, and how we can different arrays, different sizes. So that's all about Numpy. After learning Numpy, we will move on to using these 3 libraries together. And then you will see how we can use different importer and exporters. That means we will be importing the data, we will be exporting the data, and how we can use 2 libraries together because we absolutely need GDAL and Raster Data libraries. And then how we can open and visualize data, how we can add color ramp. As you know, in Raster Data, we would like to add, let's say, elevation map. We would like to add the colors for really low elevation and then higher elevation and medium elevation. We would like to show them using a color ramp. How we can add the color ramp, and then what are the data properties that we can access using Raster Data. And then if we have many bands, then how we can use all bands, or maybe how we can use one band, how we can plot them and then plot them together, plot them separately, and then save them. At the end, I added an example and then how we can do similar work that I gave you in lab 6. How we can analyze our Raster data and then bring in the Raster data into Jupyter. And then on Jupyter, how we can access the data properties, and then we can access some other properties and then store them and then combine different elements together. And then at the end, we are going to save them so that we can open it on not on Jupyter session, but separately, let's say in a PDF file or maybe in a image file. Okay, so let's start talking about what we will be doing on Numpy. So in Numpy, what we basically do, we actually work on numerical data set. It's more like a matrix, and then different dimensions we have. So you can see that I gave you a little bit of a background of Numpy, and then we have lots of help available on Numpy, how we can install them in different IDEs, and how we can install on Conda. And I gave you instruction how you can install it on from Mini Conda. I hope you already did that. And how we can work on in dimensions. We will basically work on 2 or 3 dimensions. We're not going more than that. and then you can see more information on NumPy is available here. That's the website for NumPy. You saw we have dedicated website for Matplotlib, and then NumPy also has some important information, many examples, powerful tools, how we can work on, all are available there. Okay. So NumPy, you can think of it's a grid of values, and then it has to be on the same data type. And it's indexed by a tuple, so you will see that whenever I will be creating some array, then how we can create them, how we can do some mathematical operations on them, then it will make more sense. We can have many dimensions, so you can see that dimension is the number of dimension is the rank of the array, so that means where it exists. So if you remember, we use the in a list or tuple, we can access any of them, so we have to index them. That's a similar thing that we can do in NumPy array. We can index them. And shape of an array, that means in a tuple or list, we are giving the size of the array, and then what's the dimension and how many rows, how many columns we have. That means we can also find out what's the shape of an array. If it's too big, then we cannot see everything together, but if it's a small array, then we can see what's the size of that array. And properties of array, so we can take a look what's the shape, what's the data types that we have in an array. At first, we need to install libraries. So you can see that we are installing GDAL. I will talk about GDAL and Raster Data later. And then we also need NumPy, and then I say that I'm going to use NumPy, but then again, if you want, you can use one of these lines. I gave you both just in case you want to know. If you want to know why we are not only using NumPy, if we use NumPy, then that's fine, but I gave it a short name so that whenever we call them, we don't need to write NumPy. We can just write NP. So we will be using Matplotlib, all the libraries inside Matplotlib, and then basically for plotting we will use the library plots. That is, within Matplotlib we have other libraries. We will be using pyplot, and in pyplot we are saying that we will be calling it as PLT. That's easier to call. And then we already installed Raster, and we are only going to use some libraries within Raster. So you can say I used plot, and then we will be calling them as show. So you will see it later how I'm calling them. The first one is we have some arrays. Let's look at this example. Over here we have OK. So I just gave it a name, and then I say that we have 4 elements in there. And I would like to know what's the shape of this array, what's the data type, what's the dimension, what's the size. And then I printed them, because in Jupyter you saw that we cannot run one line. That's difficult. It's not difficult, it's not possible in Jupyter. I couldn't find it. I told you if you can find it, you can let me know. So that's why I printed them separately. So at first I just created an array, so you can see. That's an array, and then after I create that array, then I printed all these elements. So I say that show me a printout. You can see I did not import these library. That's why it's not producing the output. So let's import the libraries, and then we can see now it works. We say that what's the array we have. Okay, we have 4 elements there. So you can see that it says the shape of the array is 4, because we have 4 elements there, 4 rows we have, and 4 elements we have, and then the data type is integer. So you can see integer we have, and then dimension is 1, because we don't have more dimensions. If we have 2 dimensions, then it will say 2 dimensions. That means in x-axis, y-axis, and if we have more axes on top of 2, then it will say 3. And then we have 4 elements there. That's why it says the size is 4. So previously we used integer. Now I added some decimals values in there. So you can see I said maybe create an array, add decimals in there. And what's the data type, what's the size? So I ask it to show me all the printouts. So it says that in OK2 we have many numbers. That means from 0 to 10, it's actually gradually increasing. So you can say 0, 0 0.1, 0 0.2. That means the gap is 0.1. And then up to 9.9 we have. And then data type is float because we have decimals in there. And then size is 1. We don't have more of the dimension. If we have one more pieces of block, then we will have 2 dimensions, and then we have 100 values in there. That's why the size is 100. How we can create an array? We have to create a list of integer and make it an array. So you can see that we are creating a list of integer, and then using the tuple sign. That means the bracket, the first bracket, or the parenthesis we are using. We are saying that it's actually an array by using this function np.array. That means we are using numpy and then creating an array. For creating a list, so you can see that we created a list of float values using the decimals in there. And if we want to create, let's say, values should be all 0. That means all the values in an array should be 0. Then you have to say the numpy and then use zeros. Then it knows that you are only asking for 0 values in there. Then how many rows, how many columns should be there, you can mention that. Same thing for ones, same thing for any specific value. So you can see that if we want to create an array with R rows, C number of columns, and then all values should be 8. That's why it says that np full. That means full of these 8 values. Let's try them here. If I try that, so you can see that it's creating only array with only 0 elements, and then only ones, and then you can see it uses this t1 variable, and then we converted it to an array. Then you can see over here I'm calling it, as I say, that's the 2 rows 2 columns. Same thing, 2 rows 2 columns, but it's full of value 8. So that's how it works. That's how we can create an array. Similar ideas for random numbers. That means whenever we don't want to provide any number, we just want to create some random number, then we have to use a longer function. That means 2. You can see numpy rand int. We have to use this one, and then this is a bigger function right now. What's the lowest value, what's the highest value there can be, and what's the size you want. That means how many values you want in there. So I say that how about give me tens of them, and then I provided other parameters, the lowest and highest values, and I say that I also give me what's the data type. Data type, it says integers, and then the lowest and highest value. So you will see that there is a difference because it takes the lowest and highest values. If you run it again and again and again, so that means it takes the lowest value, it's not taking the highest value. That means it goes a little bit less than what you provided. So you can see we're never getting 5. So every time you run it, it's going to change the value because it's a random number. And how many random numbers? So we could have 1 value could come twice because the size is 10, and between 0 and 4 we don't have that many values. That's why we have repeated numbers. And then I created values. I say that between 0 to x and then size, that means it will start from 0 and up to this value, and then the size is 10. That means I say that from 0 to 1, it's not going to give me 2. So you can see every time it's changing. So I say that give me from where to where. Instead of that, I say that only I gave a number. That means it will be the highest value, just like the like what we had in there. So if you change it to, let's say, 4, then you will see it's giving you between 0 and 3. That means those 0, 1, 2, 3 will show up in your array. Okay. If I ask you to create 20 random numbers between 0 and 2, that means you have to go a little bit upper than 2. So that means up to 3 we are asking. That means it will give me 0, 1, and 2. And the size is 20. There will be lots of 0s, lots of 1, and lots of 2s. So you can see. And you can print them, the dimension. So I say that show me the dimension. So it says that the dimension is 2. Now you can see that we have dimension 2. Previously we saw that we have dimension 1. Now I actually divided it. So I said that give me random numbers. That means up to 2, 0, between 0 and 2, but the size should be divided into 3 rows, 5 columns. So you can see we have 3 rows, 5 columns. That means this is actually in 2 dimensions. We have values. So this is 1 dimension and this is another dimension. That means in 2D we have our values. Previously we only had 1 row. That means there were no dimension. Now we have 2 dimensions. And then you can also ask only for 1 value rather saying the size. So you can see that it's giving us the random numbers between 0 and 1. And then how many random numbers it will give you? I say give me 5. That's why it's giving me 5. So you can say use a little bit different function than NP. NP is same. You can say NP or you can say Numpy. So I say that Numpy give me the numbers. Give me 5 random numbers between 0 and 1. If you need that, you can say it this way, or you can say that over here. You can say no, I just want size 5 and then between 0 and 1. That's another way of getting random numbers. Basically, you will see that people ask for random number between 0 and 1, and then what's the size of your population, you can multiply by that, so that you can get a get the values or IDs you want from your data set. Here I gave you an example. So you can see that if we have 2 dimensions, then you can see that we have 2 axes and we have shape of 8 versus 2A. That means 8 rows, 3 columns. We have 0 axis. That means this the 1 dimension, that's the another dimension we have. Same thing for if we have 1 dimension. You saw that before. That means we only have one big row or small row. That doesn't matter. So you can see that we don't have any other dimension there. That means that's actually 1 dimension. If we have 3 dimension, so you can see that we have dimension 0, dimension 1, and dimension 2. So that means basically we will be working on 2 dimensions, but we could have 3 dimensions as well. When we are, you saw that before when we were creating an array, That means at first I created a list, then I added parentheses so that we can create tuple, because in NumPy we have to basically work on tuple. So I said that give me 2 by 2 array, and then 2 by 2 array, you can see that B is 2 by 2 array, and then in that 2 by 2 we added all values should be 1. That means all values are now in here is 1, right? And I said that how about divide them, so you can see divided them into 4 by 2. That means we are, let's say we change the B to the NumPy, and then we added more in there, and then we printed the array, and we said that you can see that we have B array in here, and then we have 4 rows, 2 columns. First I created less, now I created more, I gave it a name. Then I said that how about change the 0 0. So you always have to start counting from 0. So you can see that we have 2 columns. First column is column 0, second column is column 1. First row is row 0, row 1, row 2, row 3. That means we start counting from 0. So row 0, column 0 is 1. That means that's the row 0, column 0. So we say that change it, that means we index it. We say that I'm going to locate my row 0, column 0. Then I'm going to change the value, give me the value 9. That means I changed the value of 0 0 to 9. So you can see that it's changed it. I located it and then I changed it. That's what we call slicing. Let's do more slicing. So you can see that you can actually hide it at the first line, and then we can say that we created the same one. Now I say that how about change the row 1, column 0, and then give it 0. That means I'm actually replacing the values, and then row 0, column 1, replace the value to 0. So that means everything was 1. Now I am changing 3 indexes, and then I'm going to change it to 9, 0, and 0. And then let's print them, or let's say B. Now you can see that it's changed to 9, and then 0, and then 0. Similar ideas for here. I think I added the same over here. Yeah, exactly same. So we don't need that. Okay. So in this activity, I told you to write some code, and in this code you are going to write about creating an array, same array I gave you, and then you have to let me know what would be the array look like if I change it to one of the value to 5, and how I actually did that. What does this means? So you need to investigate that, identify it, and then try to interpret it in here. What I'm going to change and how it's going to look like and why is that. So more slice and dice. So we actually created some random numbers here. So you can see that random numbers ranges from 0 to 10, that means 0 to 9 it will be, and then we are going to get 2 rows, 4 columns, and then we are going to print it. So you can see 2 rows, 4 columns, and if I print it again, so you can see that every time it's going to change because it's a random number. If you want to slice them, slice number 1 1, that means this is row 1, column 1. So we are going to locate it. So you can see this is 1, and if you want to look at the number 9, what it should be, try to think about it and try to find it. So I say that I'm interested to select the second row, second column to the 4th column. That means I'm going to select the I said what's the column number, so I say it's from the number column 1 to column 4. So you can see that column 1 starts here and then up to the 4th. That means this is 0 1 2 3. We don't have the 4th, that means it will go up to 3, and then it will select row number 1. Row number 1 is this one, and then column 1 to 4, it will give me these values. So that means I'm actually locating these 3 values. Okay, so that's how we can index them. That's you actually learned before. So you will be working on this second activity. In this activity, I ask you to make a 3 rows and 4 columns array, and then the values should be between 12 to 24. Create that array and then give you a solution here. So you can write your solution here. After activity 2, now we are going to work on NumPy math operations. So you can see that the math operations are similar to what we do using a calculator or any other program. Also, we learned before how we can use the math operations in Python. So you can see plus, minus, multiplication, division, and then floor divisions we have. We can also work on the powers, and we can use the symbols directly, or we can say that now I would like to add a function. For adding 2 arrays, we can add, you can say add, or maybe directly add them. And then multiply is just the multiply symbol. You can use that, or you can just multiply them using the multiply function. Same thing for sum of all elements. So you can see that that will make more sense if I show you some examples. So you can see I created some arrays. So you can see we have more dimensions there, and then we have smaller array than the previous one, than X. And then if you want to join them together, or not joining them, just adding the values, that means you can see that we have only 3 values and we have more values over there. So that means each of those elements will be added one by one. And then we are going to create Y. So you can see we are joining 1 with 1. That means the first value will be 2, and then second value will be 2 plus 0, and third value will be 3 plus 1. And next it goes to the next. That's how it's going to add element by element. Usually you saw maybe in matrix it should be on the same size, but in NumPy we don't need to have the same size array. We can have different sizes to add them together. So you can see this example I added here. So we have the 2 arrays, small and large, and then we added them together. The plus operator, the you can also say that let's use add, and then we will get the same array. So you can see the same values we are getting using plus or using add. Plus or add, same thing. And then adding element by element, you can see when we are doing element by element by joining the 2 same size array. X and Y are the same sizes, 2 dimensions, and then 4 rows, 3 columns, we join them together. And then you can also do it for other arrays. I gave you more examples how you can add, how you can multiply, how you can subtract, how you can divide some messages, because you know we need to find Q first, and then we changed one of the value, we multiply by itself and add them, subtract them, and then divide them. Because some values are 0, you will see that it's not going to give us any value, because 0 cannot be divided by 0. It will give you some infinite values. In activity 3, I ask you to create a 3 by 3 arrays with 1s, 0s, and 4s, and add these 3 arrays together. That means one of them will be 1, and then only 1, 3 rows, 3 columns, only 0s, 3 by 3 rows, 3 by 3 rows, 3 columns, and then values of 4 should be in 3 rows, 3 columns. That means you will create 3 arrays, and you have to add them together. You have to combine them into one array. I also actually use the solution here. I'm going to remove that. Let me show you so that you can do it. So I'm going to remove this solution so that you can create your own solution. So you can say I created PQR, and then I say that I'm going to join them, and then in the next one I actually combine them. So you can see PQR, I created another array, and then in that array I join them so that I can get 3-dimensional array. So in your case, you have to create your own. So I'm going to remove that part so that you can work on your own array, and then work on these 3 questions. Okay. So we are doing the same thing. We said that we are going to retrieve the middle position in each array. So that means we created F before. On here you will create, if you create an array named F, so you saw that I created, let me show you again. Let's print F. So you can see that F has these 3 dimensions. So whenever you are going to, when you will have this F, first you need to create that F array. After creating that, I said that how about you are going to retrieve the values from the middle position in each array. So that means from each of this array, you are going to give me just the middle position. These ones. Okay. So you can see, I said in all of those arrays, I actually need the middle position. That means 1, 1. So at first I said that I need to select all of them, and then from all of them, give me the middle position. That means 1, 1. So at first you have to say from where to where we are going to get. So you can see 1, 0, 4. Then I say that how about give me all yields of 3-dimensional array. That means I basically ask for everything in the array. And you can say that nope, I just need the last one. That means this is the 0 array, 1 and 2. So I say that this is from the last one. Only give me 0, 0 position. That means this one. That's the 0, 0 position. So there are more built-in functions to explore. So you can explore more if you want to. I give you more functions so that you can work on those. Now we have some fun stuff. So you can see that when we are going to mix them together, the Numpy and Matplotlib and Raster, so we have to call in all of them. So you can see that we can create plot just like you learned before using Matplotlib. So I'm going to use the Matplotlib, and then over Matplotlib I'm going to plot the array. So this array, we have the values in 3 rows, 3 columns, and then we are going to plot them. So we created an array, and then we are going to plot them using some numbers. That's our objective. So you can use different colors. So you can use color ramp, or you can use single color, or many different colors. I just gave you an example color. So you can see we can use any of them. So I just use CMap. I said CMap gave me any of this color. And we can have a color bar as well. So for color bar, you have to say that plt give me the color bar. That means if we are using jet, then it will give you this color bar on the side of your graph. So you can see that I created an array, and then I said that show it to me in a graph, and I did not give any color. That means it's going to use a default color if you don't mention it. Creating the array, and then plotting them using the IAmShow. Then you can say that in this IAmShow we are going to use the color bar winter. So that means we are going to use, you can use any of them. You can see terrain, you can use the flag, and then I use the other ones from outside. So I said you give me that one and also give me a color bar. So you can see more green and blue, and then you can say use jet. So jet is here, so I'm going to use this one. So you can see it's giving me that color bar. That means what's the number we have and then the color we have. That means the darker blue is for 1, and then we have yellow is about number 6. So you can see the value is 1. At first it's 1, 5 and 9. That means this is 1, 5 and 9. So for 1 we have the darker blue, and then for 9 we have the red color. So that's how it works. So it's actually dividing the area into cells, and then it adds color based on what's the number you have. So we are creating more. So you can see that I created 3 rows, 4 columns, and then the values are from 12 to 23. So that means whenever we have value 24, it will give me some color here. It will never be 24, it will be always 23. So you can see it will be from here. That means if it is blue color, it's actually lower values. If it is the reddish color, that means it's actually higher values. Similar ideas, it's a longer one. And then we have the color bar. We created the array, and then we also changed them. So you can see I created the array in a different way. So I created the array at first making a range. Then I said that divide them into 20 rows, 10 columns, and then change some values. So you can change it to, let's say, 100. So if I use 100 in here, that means 2 by 2 will be somewhere here. 2 by 2 will be here, somewhere here. And then if I change it to 100, so you can see that the value changed to number 100. That means in here. I hope you saw that. And number 5 row number 5, and then column number 3, I think somewhere here. And then if I change this value to, let's say, 180, let's make it 180. And then you can see now it's changed to a reddish color. Okay, so this is how it's going to work. That means we are going to divide them into cells, and then based on the numbers you have, it's going to add the color, and then based on the color ramp you choose. We are going to use different libraries. So I told you before, so we are going to use the GDAL and Raster a lot. So in GDAL we actually source the data set, and then we actually use this GDAL library so that we can use other libraries. That's really helpful, but you'll see that if other libraries, if you want to use them without GDAL, you cannot. This is pretty handy for other libraries. And Rasterio, we will be reading and writing geospatial raster datasets specifically, and it's really easy to use. If you want to use Rasterio, you have to employ GDAL. So that means one of them is this is the basic we have to use. Then after that we can call in Rasterio. So when we are going to open any raster dataset, then you have to say that it should be in an open mode, or if you want to write something, then it should be in a writing mode. That's what we did a long time ago. Reading mode is R or R+, writing mode is W or W+. So you can see that we have to call in, we have to read them, and if we have multiple bands, then we also can specify which band we want to use. If we have 3 bands, then you can say that which band you want to use. And then you can see that to open any raster dataset, and then if you want to write something, then you have to say that open that environment using the Rasterio, and then we are going to call in the name, but at first you have to say with Rasterio, and then open the name of the file, and then mode is, you can say mode is writing, and then profile will locate that Rasterio dataset, and you can also say that I'm going to write it out in a new file or a new disk. I gave you all the packages again, just in case if you don't have it, and you need to locate your data. So on your Canvas page, you will see that on this week 12 session 1, that means that's the first session we have, I gave you the data set. That's the data set we are going to use. I gave you a few raster data. So you need to download it and then unzip it and keep it in a folder, and then you can call in. So you can see that I located the data. So I say that where is it, and then we are going to use the first one is DEM clip. That's the imagery we are going to use. So I just gave it a name, read the data, and then I'm going to plot it. So using Rasterio, we are going to read them. So you can see that we are reading the first band, and then we are going to use this partial reference. So you can see profile, I gave it a name. I says that what are the spatial references we have, we are going to use that. That means going to copy the spatial references from this data file. After reading it, now it's time to visualize it. So I said that I'm going to visualize it using the Matplotlib, and then the color ramp, I'm going to use this one, but you can use other ones as well. I also asked for a color bar. So you can see that it's showing you the raster data, the elevation DEM, that means digital elevation map we have from an area, and if you use different color, it will give you different color. You can see that what are the values in there. After that, you can say that what are the data properties, and then what's in the mode. So we say that it's in the writing mode. It will give you W, and then what's the name. That means the name of your data set. So I say that I'm asking the name again. So I say that that's the one I'm going to use, and I change it. Right now I say that print, the SR printing the data set and the location. And right now since I called it again, it's in a reading mode. So that's why it says it's in a reading mode. But if I ask it for the previous one, if it's in a writing mode, then it will tell you that it's in a writing mode. And I'm going to reading all bands. So you can see that in this clip, I clip some area so that you can easily work on this data set. So you can see I use the another raster data. So I say that read that raster data and then use all this partial information over there and then plot it. If you want, you can plot the bands separately. So you can see that I'm using the Matplotlib, just like we created some subplot. So I'm going to create the subplot. So I say that I want to create 3 plots, and then in those 3 plots, the first one will be the first band, second band, and third band. So that means I'm going to have 3 plots, since I said that the 3 by 1, that means 3 column, and then 3 rows, 1 column, and then this is the first one. First one is the color blue, second one is the green, and then last one, the last band is red. It doesn't look nice, so you can see that it's covering the x-axis values. Maybe it will be better if we draw them side by side. To draw the side by side, all we need to do is to say that we are going to create a plot side by side. You can see this link, and then from where I found that this is so useful, if we plot them side by side, now you can see them better. So I added more parameters, and then I said that how many rows, how many columns, what's the figure size, that means each of them, what should be the size, what would be the resolution, and then I added few parameters that I found on this site. And then green, red, blue, you can use different colors if you want. So over here, I showed you how you can save bands in a directory. That means I actually going to be in a writing mode, because I'm going to save it. Save the bands, that means writing out and then saving them. So you can say that I'm going to save it. If you want to save them, at first you need to read it, then you can save them. So you can see we gave it a name, and then we said that I'm going to give it a name, and then every time I'm going to use the different bands, and then I say I'm going to save it. But for saving one band, you can see that for saving one band, I specify which band I'm going to save, and then I say that the name of this output should be the spot clip out. That means I'm going to save it. Let me show you if I plot them. So that means both of them I will show you. Spot clip out band 1. So that means first one is the all bands I'm going to save. So I say that I'm going to save everything, and the next one I only saved one band. So spot clip out and then band 1. Let me show you where they are. Okay, so you can see that in my folder I saved the spot clip out, and then I saved the one band. That means you can see the red one. I saved them. So you need to say where you want to save them, and then it should be in a writing mode. And then spot, you actually defined them before, so you can see that I called in, and then I gave it a name spot when I called in, when I read them. After reading them, I plotted it, but then again over here I use the same name. So I say that I'm going to save those, and I only saved one in here. Here at the end, I gave you an example, actually a few of them, so you can see that similar to lab 6, that might be helpful for you. So I located the data set. Where is the data? Then I say that I'm going to locate some areas, and then based on what are the values I have. So let's say I'm interested about the digital elevation more than 300, or maybe I'm interested less than 700. So that means you are going to locate some cells, and then that's your objective. So you will see that we gave you some objectives. Based on the objective, you have to look at some of those pixels or maybe some of those cells. So that's what I was doing. So different raster data I had, and then in this raster data, we have those cells. Each cell has the value, and then based on the value, I look at some cells, and then I actually combine different cells, and then different values we have, different rasters, and then combine them together, and then try to see where I'm actually interested in. So at first I created some list. So I said that I'm going to store everything over there, store all my mask, that means all my cells over there, and then I'm going to store all the profiles that I'm going to create, and I'm going to save it there. It's a way of storing them. Every time I will be selecting some cells, I'm going to store there by appending them. And then I say that use the cut block 2009. That's the raster data I have, and then I read it first, and then I use, and I'm going to use the projected information system we have in this file, and I say that I'm going to store it in store 1. That means over there it will be stored. So you can see I gave it a name, and then I'm saying that I'm going to store it there. So every time I selected my objective cells, then I'm going to store it there. So let's run that part, and then every time you can also print any of the element you want to see. That might be a good idea to look at them. And then using the rasterio, I'm going to open the data digital elevation map, and then over there we are interested, as I said before, where we have the values more than 300, less than 700, and then I say that I'm only going to use them and store it in my store 1 over here. After that, I use the other data file, and I'm going to read them, because that's the thing you have to do whenever you are working on raster data using rasterio. So you are going to read it first. After reading it, then your system knows that yes, you have an array of those raster data set, and you created the array, and then you are going to look at your desired cells. And then I said I'm going to calculate some vegetation index, and then I use the data set, a few data set, and then I said that I'm going to create the vegetation index using the, you can see I index them. This is the data set I'm going to use. I gave it the name. You can give it another name. Rather saying data, you can say spot, or maybe spot 1, or anything you want. So I'm going to use which band, you can mention that, and then which you can index them. And then I say that I'm interested about which values. So you can see I actually say I'm saving them and storing them in my store 1 by appending them. That means all the values, all the cells I'm interested in, and everything I'm saving in there. Then I'm going to combine everything into one mask. So you can see that I'm creating a Numpy array full of all the vegetation mask, and then everything I'm giving 1. That means this is the one I'm interested in. That means I'm actually separating them, and then I stored them, and then later on I will show you in the final mask what we can see. So you can see that whenever we have values we are interested in, we save them, we appended them, and in the final mask the items you can see inside, it's a smaller one, that's why we cannot see it better, but these are the areas where I'm interested in. And other areas, I say that give a single value, that means single color. Everything else, the areas I'm interested in, it's actually one type of color we added. If you don't add a color, it will just use the default color. Now you see that I'm going to save this map into my folder. So I say that area selected, that's the area I'm interested in, and I'm going to save them. I also gave you in the dataset this area, selected area, so that you can see that what I have saved. And then if I save them, then you will see that it's going to be saved in your folder. But the issue is that whenever you look at it, it will show you a black color. But whenever you will open it in ArcMap or ArcPro, you will see those colors. So you can see that wherever we have black color, that means we said this should be 0, and then my desired areas color is 1. That means those are the white areas, or you can give other color, other values, up to you. Let's say we have fire and then non-fire. Fire is 0, and then not the areas that we don't have any fire, then you can give value 1 or value 0. It's up to you how you want to add. Over here I actually added value 1 for the areas I'm interested in. So if you want, you can save it in a different way. If you want, you can just save one band. And I just showed you how you can save one band. That will give you the same, because it's actually a black and white color. If you want, you can give it other colors too. So that's it for our Numpy, Matplotlib, and Raster Data. I hope you enjoyed. Thank you.